Hi everyone, welcome to our 27 CSS YouTube channel. This channel provides you CSS training video courses. One request from our end, please like, share, comment our videos and do subscribe to our YouTube channel and press the bell icon. Okay, this video talks about the magic inside CSS. So what exactly it all means? Let's begin. Yeah, the prerequisites for this course is please do watch our other CSS training videos. Those are Introduction to CSS and ZOS storage concepts. We have provided the links below in the description. Please check them out before you start watching this video. Yeah, the learning objectives of this video are you will be learning about different components that build CSS region, and you will learn how big is your CSS region and CSS region JCL, different ways to bring up a CSS region, and you'll also learn about CSS initialization as well. Okay, this picture tells you about how a CSS address space looks like. If you look at this core or the center part of this picture, it is a replica of your CSS region, and these are the various components which revolve around this in building up the CSS address space. This DFH-zip is the primary program which is responsible for the initialization of your region, and how big your region has to be is defined by these parameters called JCL and memlimit. Most of you might have used the region parm in your jobs. It talks about the same parm, and which we're going to see in depth in the coming slides. And apart from these, what makes up a CSS region is this DFH-zip program, which takes a lot of parameters, which we refer in CSS world as system initialization parameters, or in short referred as SIP. If you see here, there are multiple SIP parameters which are provided to the DFH-zip program, which is mentioned in your region JCL, and this takes all these parameters into consideration and builds up your region. And apart from this set Parms, we even provide the various product libraries under steplib like SCY auth, STFH auth, STFJ auth, and a few LE libraries like skirun2. And apart from the DDs you see in your normal job, there's a special DD which is reserved for CSS, that is your DFH RPL, where you provide some product libraries like STFH load, and this is the DD where you provide all your application load libraries as well. And apart from that, you also provide the LE load libs as well, like CICS and skirun and 2 datasets. Okay, and apart from this load libraries, you even need to provide some datasets for your CSS region to come up and use it for various purposes. So all these data sets, the SIP Parms and the product libraries and your application libraries and the LE libraries, all together supply to this DFH-zip program, which consumes all this as input and brings up your CSS address space. Okay, let's see them in detail. Yeah. First, let's talk about the region parm, which we have seen in the previous slide. Okay, the region parameter is one of the important parameters, not just for CSS alone, but to any job which you run in your mainframe world, whether it could be logging into your TSO or running a job or any other subsystem, you need this region parm, right? So yeah, this region parm specifies the amount of 24-bit and 31-bit storage. That is the storage below the bar. So this region parm is the one which specifies how much amount of storage you need it for bringing up your CSS region. And the way you set this parameter is either you specify in a job statement of your CICS JCL, or you can mention it in your step exec statement of that particular CICS region, or you can have an installation ZOS installation exit called IEF USI, where it can limit the size of region value. And here there's example which talks about how to mention the region equal to Parm. Here he is mentioning in the exec, the step where you supply dfh-zip as your exec program and you pass on the region equal to value. So here it was mentioned as 0 meg. And let's talk about the mem limit later in the coming slides. And once you set the region value, one thing we need to keep it in mind is we cannot alter it when the region is up and running. So if you want to change the region value, you should definitely bring down the region, make the changes, and bring it up to pick up the new value. Okay, and the maximum possible region value which you can mention for a CSS region depends on this formula. Like as we spoke about a typical ZOS address space in our last video, that is ZOS storage concepts. So I hope you have watched that video. So this talks about the size of the private area. Okay, and if you minus the system size, that is the 16K, and the rest of the LSQ, SWA, and the subpools, so then you get the maximum possible region size which you can allocate for a region, right? And your region value also includes the DSLM, EDSLM, and the CICS kernel and MVS get means as well. So when you mention a region Parm, you need to keep all this in mind and then decide your region Parm. So whatever you decide, it's always better to have some increment to it so that it will suffice your future needs. Like you come up with a value, just add some 20-30% to it and then provide it under region equal to Parm, so that even if some workload gets increased in that region, so the region will be able to handle it. Okay, and in few customers, like they do all this and they put a value, and few they just take the easy path, that is you just mention 0 meg. So what happens when you mention region equal to 0 meg is whatever storage available at that point when your region is trying to come up, so that will be taken as a region value. So yeah, if you have too many regions and you cannot invest time in tuning each region size of every CSS region, you can choose that path. But if you can, like, better try to code a specific value to your region Parm in a region CSS region JCL. Okay, this picture shows you the typical 31-bit address space map. So when we talk about the private area, below the 16 meg, it covers the LSQA, SWA, and the subpools, and the user region area, and the system region. This is the system region which we were subtracting to calculate the region value. That is like 24 minus 8, it would be 16. You need to eliminate it. The system reserves it for itself, so you cannot use this area, and you need to even consider the size of this LSQA and this part. And the same will be above the 16 meg line. So you get this extended LSQA and all these subpools. So, but only difference is you do not have a system region like you have below the 16 meg line. So you take all these values into consideration and then you can choose the value for the region Parm. Okay. Though the theory says you can claim up to 2 gig, but there are other areas which are preoccupied and you need to keep all that into consideration when choosing region equal to size. Okay, this is how address space looks inside CICS. Okay, it's a different way of representing an address space. Okay, if you see the outer box which is in yellowish color, this is your 2 gig address space, and out of that you need to um, uh, ignore the common storage because it's already reserved, and the leftover space is the blue space, the blue rectangle, and in that again you need to uh, give up the system region, that is 16K, and the high private area which is below the line and above the line, and rest whatever remaining area you have, that you can code it as your region palm, right? And again in that you have a sitpalm called EDSLM and DSLM. The DSLM sitpalm takes care of 24-bit storage below the line, and EDSLM palm takes care of storage above the line. These are the CICS DSAs, and whatever you allocate for this is taken out of the region palm. Okay, and the rest of the area is used by the CICS kernel, LSR pools, and MVS get mains and all that. So you need to, when you set region equal to palm for a CSS region, you need to keep all this things into consideration. Okay, so ultimately this region equal to attribute decides like how big your CSS region is. Okay. Yeah, and coming to the mem limit palm, this palm limits the amount of 64-bit storage that is above the bar storage of a CSS address space. The region takes care of below the bar storage, and mem limit takes care of above the bar storage. And the ways you set up this mem limit is almost similar to how you mention a region equal to palm, that is through a job statement or the exec statement, which is coded at a step level, and you can even control it by the ZOS installation exit, that is IF USI, which can override the mem limit value. And in case if you do not mention any mem limit value, then the system takes the default. Mostly the default would be 2 gig. Again, you need to consider your MVS system programmer, like how mem limit is set in your customer environment, so that based on you can choose which way you have to code it. Okay, and this is an example where he has coded a mem limit at a step level, that is the exec program dfh zip level, and this value again each CICS version comes up with a minimal amount. Must required value. You need to mention that amount of storage. Like 5.3 might come up with 6 gig, and other versions might go up to 10 gig as well. The latest versions are available as on date. Okay, so this you need to check the CSS manual and code the minimum value which is required for that version, and on top of it, based on how much you are exploiting the 64-bit storage, so that you need to choose a proper value. Okay, but if you do not mention the minimum required value for a particular version of CSS, your region will fail to come up. Okay, and same like the region palm, even your mem limit cannot be altered when you're running in a running CSS region. To change it, you have to bring down the region, make the changes, and bring it up. And here these are the couple of CSS facilities which try to exploit the 64-bit storage as on date. One is the CMCI, which is especially used to communicate with CICS Explorer, and the CICS Applex APIs as well. The result sets of that API are stored above the bar with the latest versions of CSS, and the channels and containers are the ones which are exploiting 64-bit event processing, CICS internal trace table, the JVM servers which are used for JCX activity, and the main memory TSQs. They also get created above the bar these days. The CSS message tables and CSS transaction dump tables and the XML parse services are all exploiting 64-bit storage, that is above the bar. Okay, so the region equal to and the mem limit parm will decide how big your CSS region is. Okay, so yeah, this slide explains or shows you a sample CSS startup job, how it looks like. Okay, and yeah, here you have the exec statement where you mention dfhzip, and this is the important program which drives the CICS initialization. As we spoke about, like it takes all the zip parms you mentioned and all the libraries, product libraries, and other data sets which it needs to store information. It takes all that into consideration and tries to bring up a CSS region. Okay, in this example, if you see, like they have set region equal to 240 meg. That is what they have limited their region to. So it's always better you limit the usage of your region so that in worst case scenarios, like if something goes wrong in your CSS, it doesn't create a bigger impact. Like you choose region equal to 0 meg, it can have a bigger impact, corrupting the storage or affecting other subsystems as well. So if you can fine tune your region usage to a particular value, that's well and good. Here they have choose 24 meg for their usage. So your EDSA, DSLM, everything will be within this range. Okay. So here they have extended this exec statement with a parm where they have mentioned the zip parms. Okay. They have mentioned a zip parm called sit equal to. So what exactly this sit parm means is like all these parms can be assembled and linked in the form of a load module and passed it to CICS. Okay, so when you mention this suffix $6 means the system looks for a module called DFH zip $6. Okay, so what all parameters enclosed in that module will be treated as the zip parms by this DFH zip module. Okay. Apart from that, he has mentioned the DSLM. As we discussed, it is the CICS DSA amount of storage, which is below the line, that is 24-bit storage. Here they have mentioned it as 6 meg, and the EDSLM, which is talks about the amount of storage above the line, that is the 31-bit storage. They have mentioned it as 120. If you see, this 120 meg is well within the range of the region equal to 240 meg. Okay, so we are good. And they have mentioned some rent program equal to protect. That means they have some read-only programs which are loaded into a particular DSA called RDSA or ERDSA, where they get loaded as a read-only modules. Okay. And they have enabled the storage protection where they protect the CSS code from the application code by mentioning it as yes. And each CSS region has got a start value. Here they have mentioned it as auto. So that means they are giving the decision to CSS like which kind of start it wants. Like we have warm start, cold start, and initial start. So when you mention auto, CSS automatically picks up which start is suitable. And apart from that, last parm says SI. SI is nothing but it's a short form of SYSIN. That means like this is not the complete set of zip parms. We have even parms mentioned in SYSIN as well. So they're gonna override these parms if you wish. Okay. So yeah, in this slide, you can see like there are a couple of parms which they are trying to overwrite, like group list, LPA, Apple ID, which we have discussed. Like this is the CSS vtime relationship. Okay, and the default user, how many tasks, how many number of user tasks should run in CSS is specified by this max task value. And the rest of the parms are mentioned under SYSIN. You can hard code in the JCL, or you can place them inside a data set and code it here as a DSN equal to. Okay, and once you have supplied the system initialization parms to the zip DFH zip program, The next comes your libraries. Okay, there are few modules which should be run under authorized mode. Okay, and which should be loaded by your operating system itself or the ZOS itself. So they are coded under step-lib, and they are link edited with authorization code as one. So these modules are designed to access some SVC routines. So they are APF authorized and they are placed under step-lib. And all these libraries have to be APF authorized for you to bring up a CICS region. Even if one dataset or one load library is missing the APF authorization, CICS treats the whole step-lib is not authorized. So all the datasets what are you code under step-lib, they have to be APF authorized. And here, if you see, this is the CICS library, SCY auth. These days, they are mandating to add this library, even though whether you use CICS or not. Okay, and you have SDFH auth, and for Java work you have SDF JAuth. But with the latest releases of CSS, I think they are merging SDFH auth and JAuth, so you don't need JAuth anymore. So you just code auth, even your JCX modules will be present in that. And as we discussed in our introduction video, like CSS is basically a mixed language transaction server. So in order to provide a runtime environment for all the language CSS supports, you need a product called LE. So to install LE inside your CSS region, you need the LE libraries. Like here, they have added skirun 2 and skirun under step. And as I told, there is a specific or special DD name which is reserved for CSS alone. And here you code the other product libraries of CSS like SDFH load, and there are few more. Okay, and here not just the CSS product library, even you code the ISV libraries, which the ISV products you want to install in that particular CSS region. Like for example, here they have added the debug tool libraries, and they have added DB2 libraries where they want this CSS region to communicate with DB2. And apart from that, to have this runtime environment, they have provided the LE datasets as well. And apart from these, they have provided the application libraries as well. Okay, so and whatever libraries you coded here, the modules inside those are loaded by CSS, and they run in a state called problem state. Normally, most of the times modules in CSS run in problem state. Only there are specific times where the modules run under authorized state, which you need to add it under step-lib. And apart from these product libraries and the system initialization Parms, you need to supply some data sets for your CSS region for it to function and provide different functionalities, which we spoke about in our first video. Like CSS provides a lot of facilities for your application development, right? In order to support all that, it has to be supplied with some specific data sets. And you cannot just create a data set and tag it to your region JCL. For creating each specific data set, you have a JCL and you need to use that specific JCL, and you can fine tune it for your requirements, but a special procedure for each data set is documented. Okay, and if you come to this DFH temp, it's nothing but if you it provides the functionality of auxiliary TSQs. A developer wants to use temporary storage queues of type auxiliary. So when he creates that, they get stored in this data set called DFH temp. Okay, and if you notice, all the data sets and the product libraries, they start with DFH or SDFH. Okay, the DFH keyword is reserved for CSS. Okay, and if you are interested in creating TDQs, then auxiliary TDQs. TDQs, you don't have main memory TDQs, so it's all only one type, that is auxiliary, is possible. So they all come and sit under this data set, that is DFH intra. Okay, and CICS also provides the trace mechanism. In case if something goes wrong, you can find out the trace entries and see where there's a issue. And these come up as a pair. So you see DFH oxt and boxt. So if one gets full, the other takes action. Okay, and again it depends like whether you want to switch between these two data sets or not. Again, it is controlled by the SID Parms. And you have another TDQ called extra partition TDQ, and these are documented here in this part of the JCL. Okay, and you have some catalog data sets. There are two types of catalog data sets which CICS uses. One is the local and the other one is global. Okay, and this primarily stores the information about CICS domains and their initialization details and the installed audio definitions and CICS and remote connection details, and also that are stored under this LCD and GCD datasets. Okay, and if something goes wrong, if an event happens, okay, CICS takes some dump. Okay, and if you want a transaction dump, those are captured in these datasets, and even the dump datasets comes up in a pair, that is dump A and dump B. Okay, it's like one gets full, the other takes up, and again that mechanism is controlled by the system installation parameters you need to set up. And you can have the MVS system dump datasets mentioned in the region JCL as well. And this is another important data set, that is your DFH-CST. Okay, this system CICS system definition data set, okay, contains all the RDOs required, where it could be the system level RDOs to bring up the CICS region and for the functionality of region, or it could be your application related user RDOs as well. Everything is stored under this data set, that is DFH-CST. Okay, how this data set works and how to create RDOs, that we'll see in the next upcoming videos. But for now, this is the most important data set, which stores all your RDOs, both CICS and the user. Okay, and in case if you have this business transaction services active in your region, then you need to have a data set called DFH LRQ. And there is one more data set called DFH CMAC-D, which is used by the CMAC transaction. So if you use the CMAC transaction inside your region, it provides you a map wherein you can type in append code or a message code. You can get the details from your CICS region as well. But the suggestion or the preferred way which IBM asks you to do is better refer to a knowledge center where you get data online and up to date, because CMAC-D they stopped updating it and you might get outdated data in few cases. Okay, but still few people like to use this, so you can have it in your region JCL, no harm. Okay, apart from that, you can code files in your hard code files in your region JCL itself, or you can choose the RDO mechanism. But if you code the files in your region JCL and even you have an RDO for the same file, the region JCL will take precedence. Okay, it will override the definitions present in your CSD file. So these take precedence. Okay, and apart from that, you can CICS also provides a mechanism called sequential terminal, where you can hard code transactions in this way. So whenever the region comes up after the installation is done, then it starts triggering these transactions automatically without any user interference. Okay, so you can code that, or you can place these transactions inside a data set and you can provide it as DSN equal to, even that is possible. So this is a typical CICS startup job looks like. Okay, and it's not like all these data sets have to be there in your region JCL. It can be fine-tuned. So this is how a CICS startup job looks like. Okay, and now we are having the JCL ready. So how do we bring up a CICS region? Okay, so there are two ways we can bring up a CICS region. One is with the MVS start command as a starter task. Okay, and the other one is as a batch job. Okay, so you can submit a region and you can region JCL and you can bring it up as a job. So there are two ways. One is CICS can be brought up as a starter task and as a batch job as well. The way CICS works is all same in whatever way you bring up, but internal, if you consider the virtual storage, okay, IBM makes a recommendation like the preferred way is to use to bring up regions as a MVS starter task. So that way your virtual storage is always clean. Okay, whenever you bring down and bring up regions, you get a clean virtual storage, and it also saves the LSQS storage as well. But whereas you bring it up as a batch job, there are chances like the initiator your batch job uses might have some fragmented virtual storage already, and that can create some issues in the long run. Okay, or there are few customers who still choose to run CSS as a batch job, and during a weekend or so they recycle or they stop and start the initiators so that this storage fragmentation issue uh, will be avoided. Okay, so but not much difference apart from this minor consideration. You can bring up your CSS region as a starter task or as a batch job. Okay, there's no functional difference, or the facilities which CSS provides, it's all same, even though you bring it up as a starter task or as a batch job. Okay, so we have started our CSS region. So what happens once we start our CSS region? So the DFH program which we have provided in this region JCL, so that activates the process called CSS initialization, and it does a lot of things. And here we have just provided a partial list of the activities which it does during CSS initialization. One is the prime motto is to obtain the storage which you have mentioned under region equal to mem limit equal to Parms. And again we have different system installation Parms like TSLM, EDSLM, where we mention the storage values, right? So all that DFS program takes into consideration, and it acquires or obtains the required storage. Okay, so after that, once it has acquired the storage, then it starts setting up the system parameters which you have mentioned under SIP. Okay, there are multiple ways you mention the SIP parameters which we have seen. So whatever way you mention, DFH SIP takes all those parameters into consideration, and it configures your CICS in that way. Okay, and one thing you need to remember with the SIP Parms is most of the SIP Parms, whatever value you mention in the last, that gets overridden. Like in case you mentioned a similar SIP Parm in multiple places, so the last one takes the precedence. Okay, and these SIP Parms make each individual CICS region look different from each other, right? So with the different values of SIT Parms, the way the CSS region works changes. Okay, yeah, and after that it starts loading and initializing your CICS domains, because CICS is mainly a domain kind of architecture. Okay, so it initializes each of the CSS domains. Okay, and after the domain installation is done, then it loads CSS nucleus with the CSS modules. Okay, and then the next step would be to install all the CSS resources. It can pick it up from the CSD file and install the resources. Okay, and there are other ways how the audios are handled, which we're going to look in the other videos. Okay, not to complicate at this point of time. Okay, and after that it tries to open the required data sets based on different parameters. Okay, and in case if the previous shutdown was not done properly or did not happen in a normal fashion, so it tries to back out the recoverable resource as well. And apart from that, you have something important called as PLTPI processing. Okay, wherein you mention like which programs have to be triggered automatically when a CSS region comes up. So that processing is called as PLTPI, program initialization processing. Okay, and once the region is up, okay, to confirm that the installation was successful. Okay, you can just find for this TFH message code, or you can find for a keyword called given. So you see this message, that means your CSS has come up fine. But I would recommend, like in case you make any changes or work with your CSS region, it would be better like you scan through all the messages from start till end to ensure like nothing has failed in between. There are chances like at few places it might fail and still reach to this message. Okay, this message doesn't always confirm like your CSS region has come up smoothly. Okay, yeah, after we have our region up and running, so our main intention would be to run something, run some user programs. Okay, so you cannot trigger any transactions until and unless your CSS installation is complete. And if you see the right side part of this picture, uh, just assume this as your CSS region. Okay, and your developer has compiled and linked a program, and he has placed in this program library. Okay, and here one extra step you need to take care is wherever you place this program. For example, in this picture, it's myprog, right? You might have placed that in a program library. That program library has to be concatenated under DFHRPL. Only then your CSS will be able to scan through this library and find for this program called myprog when you run the transaction. Okay, and apart from that, you need the audios and all that to make it run. So this is the extra step you need to code it when compared to the batch. And even in batch, you place this library where you have this myprog module under the step lib. But here in CSS, you need to place that library under DFHRPL so that your CSS can scan through that libraries and find for the respective program, load it into CSS and run it. Okay, this is how the CSS is made up of, and we have discussed like what Parms make the CSS region big enough, like the region equal to mem limit equal to, and the respective program product libraries and the respective CSS datasets which provide different facilities for application developer. Okay, and what all activities involved in CSS installation and the way which through which multiple ways you can bring up your CSS region. We have discussed all that, and yeah, this is the end of the video. And thanks a lot for watching this video, and if you like this video, please do like, share, comment and subscribe to our channel and press the bell icon. In case if you have more training requirements, you can email to this ID. Okay, and thank you.